Good afternoon, everyone. I'll try not to keep you too long, and I'm just going to give you a brief outline into who we are at Geological Survey Ireland, what we do, and what we've been doing in this particular area. So the reason we got into this is taking a broad step back is that we're very aware within the survey and within the Department of the Environment and Climate Action of the challenges coming forward over the next 20 years with aggregates, particularly with the volume of housing that we're going to need and the volume of construction materials that will be needed over the next 20 to 30 years. Within that, we're aware that we have a lot of specific planning challenges, which I know that a lot of the local authorities are quite aware of. Particularly for us, we're looking at development plans in each area, construction forecasts, how many units, how many roads are we going to need, material forecasts then, in particular around the standardized materials. So where are we going to get SR21 material? How much of that will we need? How much SR16? It's very easy to look around the country at the moment and think we have ample quarry capacity in terms of what's been produced through the industry. But the reality is when you start digging into the figures is that that industry could come very close to being at capacity. And we've seen in the past what happens when you get an industry, particularly the quarry industry in the east of the country, struggling to feed the demands of a construction boom. We end up with the pyrite situation. So we're also interested in material sources, where exactly we get them, how we're going to responsibly source the material, how we're going to keep our carbon footprint low. This is going to be very important going forward for embodied carbon within buildings. You're going to have to assess how far away you're pulling your aggregates from. And remember that a huge proportion of the cost in aggregates is actually in the transporting of the cost. Once you go beyond about 30 or 40 kilometers, then the cost of transport of aggregates per ton is actually higher than the cost of production of the material. And then from a planning point of view, looking forward, we produce aggregate potential maps, and we're quite interested in making sure that resources aren't sterilized going forward, ensuring that we do have a sustainable supply of material and that the planners and the people building the infrastructure going forward will have access to all of these raw materials. So what we produce at the moment, we have an aggregate potential map. It's available on our website. I've spoken to some people in various local authorities in the planning sections about how to use that product and how to interpret it properly. We have data on crushed rock potential. We have data on granular potential, so that's sands and gravels versus crushed rock. It's a modeled product, so where an area that says high potential doesn't guarantee that that's particularly good for a quarry. It means it's a good place to go and think about putting a quarry. It doesn't replace the need to go in and actually examine the rock itself. And we have a quarry database under development as well, and we're working in-house to do that, and that's something that we're conscious of developing with NBCMSO to make sure that databases can speak to each other, and also with EPA, who have the extractive industries register, and with the HSA, who also have a register of quarries from their point of view. And all of this within the survey falls within a larger project we have called Irish Construction Materials Project. And there are essentially three pillars of that. So the main pillar that we're worried about at the moment is the suitability. So the suitability of material. And within that, we want to make sure on dimension stone, are we getting the right material for repairing historic buildings? Anytime you go down to Leinster House, you can see that there's places where the daub has been repaired and the rock they used was the incorrect dimension stone. So you have these excuse me, we have these light patches in the walls of Leinster House, which look quite discordant, and it's because they used the wrong limestone. So that's something we work with on dimension stone. We work with market surveillance, and then on sustainability pillar, carbon footprint of material, ensuring that wherever possible we can source locally derived material. And then a security of supply, the planning challenges that we have. There's no point having really good quarries that exist, but don't have their planning, aren't planning compliant, and so we can't operate them and we can't access these materials. So those are the three pillars. We're only going to really talk about the suitability pillar today and what we've been doing in support of market surveillance. So we're not a market surveillance authority. Within this has been mentioned already, within the construction products regulation, we are a competent national authority. We are a competent national authority only for aggregates. We have a bit of overlap with TII. And so they have a lot of expertise, particularly in the aggregates for road infrastructure and for rail infrastructure. And we don't really work with that. So we work very much on the knowledge of the raw material side, and then looking a little bit at the product, the aggregate products. We don't tend to look further downstream because I don't know anything about concrete blocks or concrete lintels or anything like that. Once the rock gets crushed and put into a product, our expertise ends. So we're available to help, and we're available to help anybody. If you have any issues and queries about geology or quarries, you can come talk to us. We're not authorized officers, so we can't go in and make demands of a quarries in the way that the market surveillance authority, so the local authorities can, or in the way that NBCO can. But we can make a reasoned request. And in practice, we found that anytime we make a reasoned request and we go in and speak reasonably, we haven't had a problem with working with quarries. So what does this actually look like? Well, we give market surveillance support. It's coincidental, actually. I've put up that quarry because we visit there quite regularly, and it happens to be a local quarry at the road. In the same way, if you need an architect in your state body, you can call the OPW. If you need a legal opinion, you can get the state solicitor's office or the attorney general involved. If you need a geologist in your state body, you can come to us. We are the state's geologist. We have geologists in-house, that's us, competent in rocks, and we will respond to requests related to market surveillance. When we go to the operators, what do we look for? We look for the quarry geology. So that's something we'll go out and we'll do an on-site visit. And we look for their geologist reports, in particular for the standards where a professional geologist is required. Our current activity within this, we sit on a couple of NSAI steering groups within the defective concrete block steering group and on the aggregates panel. We've supported the Donegal audit with NBCO and done a lot of technical analysis. And then on the industry side, we are available for industry as well. So if a quarry operator has an issue with a product, they can come and ask us for advice on how to make sure that their product is compliant. And then we also work on the research side. We commission research projects, and we make sure that research questions that are required to be answered in support of the development of aggregates and development of standards get correctly addressed. So I'll walk you through a little bit on the Donegal audit support, what we've done and what it looks like. We've got 15 locations of 15 specific quarries. These were producers, only quarries that were producing standardized material requiring a professional geologist. So I'll touch on that a little bit later. What do? We go out onto site, we make a visual assessment of the quarry, we check the report, we take samples where appropriate, and then we do a full lab analysis of those samples, and we'll revert to the Market Surveillance Authority and say, yes, this does exactly what it says on the tin, or no, it doesn't. How we decide what to do on a site is we work through a very simplified, well, looks complex, it's actually a very simple flow sheet. We start off and we get the paperwork from all the facilities. We go to them, we say, we want your geologist report. In actual fact, it's NBCO who do that. They'll get the paperwork, and then to us, they'll say, we have these geologist reports. We don't understand what they mean. You're a geologist. Can you read them and tell us if these are appropriate? The first question we ask is there a geologist report? If there isn't a geologist report, this is a high-risk quarry because it's producing material and it doesn't have the required paperwork. So straight away, we're going to inspect that quarry and we're going to sample the material. If it does have a geologist report, we'll review the report. We will say, yes, it's suitable material for production because that's what the geologist report will say. Or we will look through the report and we'll say, well, it's suitable, but there's a couple of caveats which have been noticed by the geologist. That's not a problem. That happens in places. You might have a lithology in one side of the quarry which isn't suitable for concrete, and the other side of the quarry is completely suitable. So if that's the case, we put it at a slightly higher risk, just as our internal risk assessment. It doesn't necessarily mean that it's poor quality or that they're not capable of producing a product. And that's just how we internally assess it. Phase 2, then we take those risk assessments and we select which sites we're going to inspect. The low risk sites, if they're visually consistent with the report and everything looks, and we know these quarries, we know these lithologies, and we can make that assessment and say, well, actually, we don't have to visit that because we're pretty confident in the report. We're pretty confident in it tallies with what we have in our own data, tallies what we have in our own maps, and we don't feel that that necessarily needs a visit. In practice, we actually probably visit everything at the moment, just because of the place that the industry has found itself and because of the sensitivities around it. It's easier and it's more appropriate for us to visit all sites. If it's a medium risk quarry, we're more likely to visit it. If we come and we visit the quarry, everything looks okay, we don't bother taking samples because we're very happy with what's in the report, with the samples that are coming back, and then we can write a closeout report. If we do take samples, we move on to our final phase. So what we do is we identify where we're going to sample. Are we going to sample the raw material rock? Are we going to sample the products? We take the samples in line with our secure sampling procedures, which that's something we do very regularly as a survey. We have a lot of sampling programs. We dispatch the samples to the lab for testing. We evaluate the results in relation to what the standard says, and then it's either a pass or fail. And we communicate those results to the Market Surveillance Authority. If it passes, it's a closeout report. If it's a fail, we get back to NBCO and the local authority and we say, guys, there's a problem here. And then we move on to the next phase. And I'll talk through an example of that. So this happened over the past couple of years. In 2021, we received a request for technical geological assistance when a certificate was withdrawn from a facility. We visited the manufacturing facility and took samples from 3 different aggregate stockpiles. Sent those off to our laboratory. We got a petrographic report back, and there was an identification of a technical non-compliance within externally sourced material. So this is material that an economic operator had bought in as certified material. And when we went through it, we said, well, actually, there's a little technical non-compliance here. So we went back to where the material had been sourced, took sample of this, it was SR16 material, and sent off a report to the lab again so that we can make sure then that we traced this back to source. And we found that the technical non-compliance we'd identified initially at the first operator was something that was real, and it was there. So we visited the manufacturing facility with market surveillance authorities. We took samples from the stockpiles, samples from the quarry face. We agreed an alteration to the quarrying plan with the operator, and we sent samples off to 2 different labs. So what we do is we approach it very much like an anti-doping case. We'll take an A sample and a B sample. So we'll go in with the quarry operator and we'll say, we want to take samples. So we'll take a sample here and we'll fill 3 bags. One is for us, one is sealed up as a B sample, and one is given to the operator. They can send it off to their lab, we'll send it off to our lab, and then we'll come back and we'll compare results. So we agreed an alteration to the quarrying plan. Essentially what had happened was there was a separate lithology in one corner of the quarry that was starting to appear into some of their SR16 material. And while that would have been fine for all of their other products, it was just SR16 it was just over the threshold limit. So what they did was they moved their production of SR16 from one face of the quarry to another face, and that completely solved the problem. So when we received the petrographic reports at the end of December, we confirmed the original reports, happy with the quarrying plan, and we confirmed the suitability of material going forward. So this is what happens on the ground, and it's a technical non-compliance. It was very low risk, very, very low values in very, very low excessive values. And so we're happy going forward that this is something that is not going to be a problem in the future. So from an operator's point of view, and it's really worth knowing this as a market surveillance authority as well, what is the geologist's role? So there are 3 standards requiring a professional geologist, 16, 18, and 21. And each of those references obviously a harmonized European standard. In the context of, they all have a version of these words. Sometimes they name the SR, sometimes they don't, but this is essentially the same wording out of each of the standards. The competent person has to be a professional member of the IGI or an equivalent professional body. So they could be a professional member, a chartered geologist in the base, qualified out of the UK, or a member of the European Institute of Geologists. They have to have established record, 5 years of practical assessment of resources, experience of quarries, experience of aggregates, and assessment of aggregates. IGI maintain a specialist register specifically for SR21. De facto, if somebody is on SR21, they will be qualified for SR16 and SR18. There isn't a specific register for SR16 and 18, but I'm not aware of anybody who does 16 or 18 assessments who isn't also on the specialist register. So the first thing you need to check if you're going in and you're auditing a quarry is who did their geologist report? Are they on the register? And it's a very simple check. Within SR16, section 3.5.2 talks about knowledge of the raw material. So we have 2 different roles here as a professional geologist within a quarry. There's knowledge of the raw material, which is the quarry, and then there is the product. So the product is what goes out the door with the CE marked on it and gets sold at the gate, sent out in trucks or ton bags or whatever way they want to sell it. So when we talk about knowledge of the raw material, we talk about going back right to the quarry face. All of the standards have wording like this. The geological assessment of the deposit should identify and map the main lithologies and relative proportions within the quarry. When you get a geologist report, or you're looking at a geologist report to see if this is up to scratch, there should be a map in it. It should tell you what is in the quarry, where the different lithologies are, and and there should be a map showing that one side of the quarry is limestone, one side of the quarry is quartzite. They all ask for a new assessment when there's a change in lithology. So if the production moves from one face to another, or it moves through a particular face and the geology changes, they're obliged to bring the geologist back in. Within SR 16, table A1 asks for the geologist to look at these particular things, not limited to these, but these are the important ones. So if the fines content is over 3% in the fine aggregate, then the geologist has to make an assessment as to whether it's suitable or not. Sulfur, total sulfur has to be less than 1% in general. If pyrrhotite is present in the rock, it has to be less than 0.1%. That's reported as a single decimal place, so 0.1%. Because it is stated as a single decimal place, we've confirmed this with colleagues across Europe. Effectively, that means that you can have up to 1.14% total sulfur, because that rounds down to 0.1%, and that's fine. So if you have a lab, for example, that reports to 2 decimal places, and you get your results back and it says 0.11% total sulfur, that's fine, because within the standard, it's at 1 decimal place. Geologist also has to make an assessment on alkali silica reaction, which is whether there's any crystalline silica rocks present, and whether there's the potential for ASR damage. And then they have to do a petrographic assessment to say that this is suitable for the use in concrete. Annex C talks about assessment of the aggregate. Again, this references 12620. And again, we talk about maps. So documentation dealing the nature of the raw material at source, and where appropriate, 1 or more maps showing location and extraction plan. If you're in a huge, big tabular limestone quarry in the Midlands, the extraction plan is not particularly that important. If you're in the Northwest in Dalradian rocks, or you're in Mayo and you're in the Southeast, and you have very variable lithology, then the extraction plan is going to be really, really important. So if you go into a quarry and they say, well, we're just pushing straight through that face, if the geology keeps changing, then there's not going to be any consistency between their materials. So what they're producing today may not be the same as what's produced tomorrow or the next day. And they need to have assessed that, and their professional geologist needs to assess that and to say, this is how we approach this project going forward. And again, it mentions within 12620, pretty much the only thing that it forces you absolutely black and white to do is that if your aggregate has pyrrhotite, you must be under 0.1%. SR 18, very similar, knowledge of the raw material, the geological assessment of the quarry, a new assessment when there's a change in lithology. Again, SR 18 is for mortar. So one thing that the geologist has to assess is constituents which alter the rate of setting and hardening of mortar. So that needs to be assessed by the geologist. If you have somebody producing material for SR 18, they have to have a geologist look at that. Again, sulfur less than 1% generally, and less than 0.1% of pyrrhotite is present. Your geologist should also be checking magnesium sulfate soundness, checking the fines quality. Again, if the fines content of your fine aggregate is greater than 3%, the geologist has to assess that and make sure that it's appropriate, petrography and alkali silica reaction. Again, with the raw material for SR 18, identify and map main material types, new assessment for lithology, and maps location and extraction plan of geology. It also says a petrographic examination should be carried out by a competent person. The competent person then within SR 18 in Ireland is defined as a professional geologist. So petrographic examination is where somebody looks at the rock and identifies what minerals it's formed from. So what exactly is it formed? So we could say that something is a sandstone or a siltstone or a limestone, but when you go in and look at the actual minerals, which is where you really find out what it's made of. So it's like saying we have a cake. Well, is it a chocolate cake? Are there peanuts in it? Is there chocolate icing on it? So the actual constituents. So we have the lithological examination, which tells you the broad class of rock, and then the petrographical examination tells you the minerals. And it's within the petrographic examination that you'll identify pyrite, pyrrhotite, any of the other sulfide minerals, potential excessive mica, whatever else you might have. Annex C in SR 18 is a very useful guide for manufacturers to the geologist's responsibilities. There's a table there listing everything the geologist has to do. And even though the same table is not in SR 21 and SR 16, it's broadly similar. So it's really good to have and to make sure as an operator or as a regulator to make sure that all those boxes have been ticked within the geologist's report. And then finally, SR21, which I think we're all probably aware of. This was one of the first ones that came in and required a professional geologist following the issues we had in the east of the country. The same wording, assessment of deposit should identify and map the main lithology. So you need to see a map. And we're blue in the face telling geologists this and quarries that when your geologist comes in, your geologists say, oh, I'll do this, 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 this. You say, no, you have to tell them that they need to make you a map. So there should be a map in your report. Documentation, dealing nature of raw material, location, extraction plan, and new assessment. And then within SR21, we have our infamous Annex E, quarterly, at least quarterly assessment of the aggregate. So your professional geologist has to come at least 4 times a year and assess the aggregate. Sedimentary mudrock, which is a particular type of lithology limited to a maximum of 10%. All of these as well. The 10% is an upper limit. If your geologist comes in and says, you can't have more than 5% of that because that's a problem, then you have to follow that. So that's the upper limit. If it's over 10%, you don't even need to ask your geologist. It's just gone. If your professional geologist specifies it, they have to do a petrographic assessment, and that involves transmitted and reflected light evaluation of sections. This transmitted and reflected light is really, really important for the identification of pyrrhotite. So when we talk about transmitted light and the petrographic assessment, what we do as a geologist, we take a small little piece of rock about the size of your thumb, we stick it onto a glass slide and we grind it down to about 50 microns. And it's so thin then that we can shine light through from underneath, and lots of different minerals react in different ways. And so we can turn the slide around and you can identify all the proportions of minerals. Pyrite, pyrrhotite, marcasite, chalcocite, chalcopyrite, all of the sulfides are completely opaque. They do not let light through, even when you grind them down to 50 microns. So you cannot distinguish between pyrite and pyrrhotite and any other sulfides with a standard transmitted light thin section. So if you meet a geologist and they say you can't distinguish between pyrite and pyrrhotite, that's incorrect. You can't distinguish in transmitted light, but what you can do is you shine light down on the slide from the top and they look very, very different. So it's very important if there is a particular question about the nature of your sulfides, about whether you have pyrite or pyrrhotite. And remember that pyrrhotite changes your total sulfur permitted amount by an order of magnitude. So if there's no pyrrhotite, you can have total sulfur up to 1%. If there is pyrrhotite, you're stuck at 0.1%. So it's actually very important if you think that there's a risk of pyrrhotite that you get this reflected light done. If it's over 1%, material is not suitable for use. If it's under 0.1%, the aggregate is deemed suitable for use. And within this is another very important statement. A level of sulfur over 0.1% is intended as a trigger action level for further evaluation. So if it's over 0.1% and under 1%, it doesn't mean it's fine automatically. It means that you need to go and check it. And that's something. So if you get a report in and the geologist report says SR21 Annex E material, 0.7% total sulfur, all good. Well, it's not all good. You need to have a further explanation from the geologist as to why 0.7 is good and acceptable in this case. And 0.7 might be acceptable because they say, well, we've seen pyrite, we haven't seen any pyrrhotite, and we estimate that all the pyrite is non-reactive. So it's a particular form of pyrite that doesn't react. And then if pyrrhotite is present for SR21, the hard limit is 0.4%, so slightly higher for SR21 than it is for SR16 or for SR18. So what do you expect the geologist to do? In summary is, number one, your geologist has to be a competent person. There's a register there. There are only 16 or 17 people on the register, so it can be difficult to get a geologist at times, and that's something that the IGI are working on. But getting to somebody who is competent and has that 5 years experience is actually quite tricky at the moment. They need to identify the main lithologies and relative proportions within the quarry. So if you go into a quarry and it has quartzite at the front and shale at the back, and they say, oh, we're only producing the quartzite, so you only need to evaluate the quartzite. Well, that's not going to fly. If the quarry has a different lithology in it, even if you're not operating it and you say you're not operating it, you still have to identify it, you still have to map it. And then within the extraction plan is where you say, well, actually, it has this big problematic lithology at the back, but we're not producing that. That's just been produced for general fill, or it's not being produced at all. And what we're using for concrete or for mortar or for subfloor fill is this really good material at the front. petrographic assessment of the product then. So this is the actual aggregate that goes out as a product. Representative samples. There's no point saying as a geologist or looking for it and say, well, you know, the quarry sent me a sample of their product. It's like, no, it needs to be a representative sample. You need to go in, you need to check, and it needs to be checked that what is being sampled is representative of what's going out the gate. So you cannot pick and choose. You can't cherry pick stuff that you think is going to be good. Within that, you need to identify the main mineralogies, the relative proportions and distribution. If sulfur is greater than 0.1%, this should be a trigger action level for further work. And if there's suspected potential pyrrhotite, reflected light examination is recommended. And then finally, the geologist needs to provide a statement of compliance for the proposed end use, which says this material is suitable for use in concrete or use in subfloor fill as an unbound, hydraulically unbound aggregate, or use as mortar or whatever it is. And that's it. And we can